Hello everybody to the next GeoBoost video in the Submodule 1.5 combination of ground source heat pump systems with other renewables and integration of ground source heat pumps in low temperature grids. And I will actually explain now how we can integrate geothermal in low temperature grids. So first of all, what is a low temperature grid? You see in the picture now the development of specific district heating grids. And the development is that the temperature level is actually decreasing if you go to the next generation. So on the far right side, so see the fifth generation grids. And the grid temperature is quite very low here, between 5 and 25 degrees Celsius. Also, this grid is designed by integrating a lot of renewable energy sources. So it's mainly not only one, and also integrating a storage like a seasonal heat storage, and also integrating cooling options here. So this is more or less the definition of low temperature grids. Also fourth generation grids actually are quite lower, but we are dealing now with the fifth generation grid, so with very cool temperatures in the grid. So how does it work actually? So what we have is here, you see also a low temperature grid. You have here two cycles, a cool one and a warmer one, and you have renewable heat sources integrated, and as I said, a storage. This is quite very important that you can balance out heat and cold and so on. So giving you an example of how we can integrate ground source heat pumps here, for example, borehole heat exchangers. Borehole heat exchangers produce a temperature from the underground, maybe about 10 degrees, something like that. And these 10 degrees Celsius is leads by the grid to the specific building units. And in the building units, you have a heat pump. So every single building unit has its own heat pump, and the heat pump increases then the temperature from the cold net, from the geothermal source to the temperature what you need in your household. So you can use borehole heat exchangers for this, but you can also use groundwater. So open loop system here, you have some wells, a well system, and then you have the low temperature network where you have a heat exchanger, but then actually leads this low temperature also to the heat pumps, again in every single building unit. But of course, there are more options. You can also integrate it in just a district cooling grid. So the district cooling grid is, of course, also low temperature. You use that for cooling. You see here a specific example where culvert wells from subways are used as a source for these district cooling grids. And then you can use the groundwater, pump it out from one side and actually inject it back in the other side. And then you can cool down data centers or whatever you need to cool, or some buildings. Of course, you can integrate ground source heat pumps also with a specific higher temperature. So we go more to the fifth generation grids here. So then you can use ground source, a heat pump, and the heat pump to increase, for example, groundwater sources by a central heat pump. And this central heat pump heats up then the grid to a higher temperature, for example, 70 degrees or 50 degrees, which can be used then to heat up the house and make domestic hot water. This can be also designed more complex by two central heat pumps and heat up now different grids for base load and for peak loads. There are several opportunities, and this example here, what you see in the picture, is an example from Paris. But of course, you can also use borehole heat exchangers by central heat pumps. So you have a centralized heat pump, a borehole heat exchange field, and this actually leads to low temperature grid, and then you can actually combine it also with decentral stations. And so you have two different heat pumps as we have seen before, and use borehole heat exchangers here. So what is the integration, or what is the design, and what is the characteristics of such combination with low temperature grids? So you have, as you've seen, several opportunities to integrate geothermal energy into these district heating and cooling grids, and all is depending on the local situation. Which renewable energy do you have here available? What can you integrate? What is the heat demand side? What is the cool demand side here? What you have to balance out. So there are several opportunities to use it, but this is really very favorite systems for the future, especially in urban areas.